Hello everyone, welcome back. Today we're going to look a little bit at quadratics. By the end of today's session, you should be able to factorize a quadratic expression and solve quadratic equations using the methods of factorization, graphing, So what is a quadratic expression? Well, a quadratic expression is an expression of the form ax squared plus bx plus c, where a, b, and c are integers. Again, we note that a is a coefficient of the term in x squared, b is a coefficient of the term in x, and c is a constant term. So what does a graph of the quadratic function look like? Well, all quadratic graphs will take this basic shape when a is positive and the turning point on the graph is the lowest point. Remember, a is the coefficient of the term in x squared. So if the coefficient of x squared is positive, the graph takes this basic shape. However, if a is negative and the turning point on the graph is the highest point, then the quadratic function will take this basic shape in terms of its graph. So now we're going to look at how do we factorize a quadratic expression. So let us consider this binomial. Now a binomial is an algebraic expression of the sum or the difference of two terms. When we expand a binomial, we are using one term in the product to multiply the other term. However, we recognize that each term is the sum of two terms. Now, because we cannot multiply by the two terms at once, we're going to use the distributive law to help us. So here, I'm multiplying x plus 3 by x plus 5. To use the distributive law to do this, I'm going to multiply x plus 3 by x first, and then I go ahead and multiply x plus 3 by 5. Then my aim is to find the sum of those two products. Let's see the result. So x multiplied by x gives my first term as x squared. Then x multiplied by 3 gives my second term as 3x. Then 5 multiplied by x gives my third term, 5x. And lastly, 5 multiplied by 3 gives my fourth term, which is positive 15. Then I go ahead and do my further simplification by putting my like terms together and simplify. There's only one x squared, so there's no way to simplify that, so that remains. Now I have 3x plus 5x. These are like terms, so I can simplify by adding the coefficients. So 3x plus 5x gives me 8x. And my remaining constant is 15. So when I expand the binomial x plus 5 multiplied by x plus 3, the result is x squared plus 8x plus 15. Now factorizing the quadratic is essentially the reverse of expanding the binomial. Because, as you would have noticed, having expanded the binomial, our result is a quadratic expression. Now, if we wish to factorize the quadratic expression, we reverse this process and therefore arrive at a binomial. So we're going to look at this process slowly and pay keen attention to all aspects so that you will be able to factorize your quadratic expressions. So now we're starting with our quadratic expression x squared plus 8x plus 15. Our aim is to separate this middle term into two terms so that our expression now has 4 terms instead of 3. How do we do this? So to find our 2 terms, there must be 2 conditions that are met so that these 2 terms that we choose will work perfectly. Here are the conditions. Let us say we're assigning one of our numbers to be P and the other Q. Then we would like to choose our numbers such that when we add the 2 numbers, I'm getting the coefficient of x. In this case, the coefficient of x is 8. So when I add the 2 numbers, I should get a value of 8. Then the second criteria is that when I multiply my 2 numbers, P and Q, my answer should be the same as if I multiplied A by C. Remember, in the general form of my quadratic expression, A is the coefficient of the term in x squared and C is a constant term. So, in this case, A here is 1 and C is 15. So when I multiply the 2 numbers that I have chosen, I should have the same product as when I multiply 1 by 15. So my P multiplied by Q should give me a value of 15. One way of finding these numbers is to factor 15. So I look to see what are the factors of 15 that when added gives me a value of 8. In this case, 3 multiplied by 5 is 15 and 3 plus 5 is 8. Therefore, my values of P and Q are 3 and 5. Now, because we are replacing a term in x, so we chose our values to be 3 and 5, we are replacing a term in x. So we use 3 and 5 as coefficients of 2 terms in x. So we will replace 8x with 3x and 5x. So 8 becomes 3x plus 5x. Now that we have our 4 terms, we are going to factorize this expression by grouping the like terms. So we are grouping x squared plus 3x as one group and 5x plus 15 as another group. Now we are going to factorize each group. So we examine x squared plus 3x. We look at the highest common factor of those 2 terms. The highest common factor of x squared and 3x is x. Therefore, we will factor out x. So we factor x out and then we go ahead and divide each of the terms x squared and 3x by x. When I divide x squared by x, my result is x. When I divide 3x by x, my result is 3. So when I factorize x squared plus 3x, my result is x, open bracket, x plus 3. Then I go ahead and factorize 5x plus 15 in the same way by finding the highest common factor of 5x and 15. The highest common factor of 5x and 15 is 5. So I go ahead and factor out 5. Then I divide each of the terms, 5x and 15, by 5. So 5x divided by 5 gives me x. 15 divided by 5 gives me 3. So when I factorize 5x plus 15, my result is 5 open bracket x plus 3. At this point, we go ahead and factorize again. In this case, our highest common factor is x plus 3. So I will divide x times x plus 3 by x plus 3. When I divide x times x plus 3 by x plus 3, my result is x. Then I go ahead and divide 5 times x plus 3 by x plus 3. When I divide 5 times x plus 3 by x plus 3, my result is 5. So when I factorize x times x plus 3 plus 5 times x plus 3, my result is x plus 3 times x plus 5. So let us look at some sample questions. We're going to solve this question using two approaches. The first is that we're going to solve the question by graphing. To graph this equation, f of x is equal to 3 plus 2x minus x squared, what should our graph look like? What's the general form of our graph? Now, the other question is this the general form of a quadratic equation? What do you think? It is, except that it is written in the reverse. Remember, we normally have ax squared plus bx plus c. Alright, so now that you remember that our graph should have a maximum point, let us go ahead and decide how we're going to go about plotting this graph. Now, we were not given a range of values, so we have gone ahead and selected a range of values for x, for which we will use our function to calculate our y values. So we have chosen values for x accordingly: -2, -1, 0, 1, 2, 3, 4. f of x represents our y values. The function that we're using to generate our y values is f of x is equal to 3 plus 2x minus x squared. In this case, we're going to be substituting our x values into our function to calculate our y values. So when x is equal to -2, we have 3 plus 2 multiplied by -2 minus -2 squared. When x is equal to 2, f of x is equal to 3 plus 2 multiplied by 2 minus 2 squared. When you simplify these, what values did you get? Notice the other values have been completed already for you. So check your values. Did you get -5 as the y value when x is equal to -2? And 3 as a y value when x is equal to 2? So special care should be taken when dealing with negative numbers. Remember, -2 squared means open bracket -2 close bracket squared. So it means -2 multiplied by -2. Okay? Also, 2x when x is -2 means 2 multiplied by -2. Just check on those things. If you did not get the value when x is equal to -2, correct. So go ahead and set up your Cartesian plane, choosing your x and y values accordingly to match the values on your table. Then you're going to look for -2 on your x-axis and go down to -5 on your y-axis and plot that point. Then you go ahead and plot the point -1, 0, 0, 3, 1, 4, 2, 3, 3, 0, and 4, -5. Your graph should look like this. Now, how do we read off the solutions from our graph? Remember, our roots occur where our y-coordinates are 0. So, wherever the graph cuts your x-axis, that would represent the roots of your graph. That means the solutions to your graph. So let us look at where our graph cuts the x-axis. All along your x-axis, your y values are 0. Therefore, your x-axis is also called the line y equals 0. At our scale here, we're using 4 boxes to represent 2 units. Therefore, 2 boxes represent 1 unit. So our graph cuts at the points where x is equal to -1 and where x is equal to 3. So the solutions to our graph here is x equals -1 and x equals 3. So at this point, let us stress the importance of the difference between an expression and an equation. So a quadratic expression is an expression of the form ax² plus bx plus c. A quadratic equation is of the form ax² plus bx plus c is equal to 0. We simplify expressions, but we solve equations. In solving an equation, however, we may factorize. So while we can factorize an expression, we can also use the principle of factorization in solving our equations. So we're going to solve this equation by factorizing. And the same principle we looked at how to factorize our quadratic expression earlier, we're going to use that principle in order to solve our equation. While we take note of the fact that our expression here is not given in the order that we're accustomed, we can still work with it because all the key components are there. So we have our C, which is 3, we have our B, which is 2, and we have our A, which in this case is -1. Remember, A is the coefficient of x squared. So we need 2 numbers such that when we add the 2 numbers, we're getting a value of B, which is 2, and when we multiply the 2 numbers, we're getting a value of A times C. Now A is -1 and C is 3. So when we multiply those 2 numbers, we should get a value of -1 times 3. What numbers are you thinking? Did you say 3 and -1? Great. When I multiply 3 by -1, I'm getting -3. And when I add 3 to -1, I'm getting 2. So using our principles just as before, we have skipped a few steps here, but using our principles just as before, we will rewrite as 3 plus 3x minus x minus x squared. Then we group our terms and factorize accordingly. Give it a try. You should end up with these results. Do you notice that the solutions that we got by graphing, we're still getting the same solutions here when we factorize?
So when we factorize here, our solution lies where we have our binomial being equal to 0. The concept here is if I have the product of 2 things being equal to 0, then either one of them is 0 or both of them are 0. What do you think? So in that case, we go ahead and equate each of the term in our binomial to 0 to solve for the respective values of x. So our values are x is equal to 3 or x is equal to -1.
Again, here the same principles apply. Always bear in mind that the coefficient of x squared is not always going to be 1. So in the case where we have 2x squared plus 3x minus 2 equals 0, we need two numbers such that when we add them, we're getting a value of 3, and when we multiply them, we should get the same value as a times c. In this case, a is 2 and c is -2. So when we multiply those two numbers, we should get a value of -4. What are your thoughts? I need two numbers. When I add them, I'm getting 3, and when I multiply them, I'm getting -4. What are those numbers? Give it a try. The solutions are here for you. Let's look at the other question. 3x squared minus 7x plus 2. We need two numbers such that when we add the two numbers, we're getting -7, good. And when we multiply the two numbers, we're getting 3 times 2, which is 6. So when I add the two numbers, I should get -7. And when I multiply the two numbers, I should get 6. The solution is here for you. Give it a try. Let me know what you think. If you have any questions, go ahead and type them in the chat. So let's summarize. Quadratic functions are written in the standard form y equals ax squared plus bx plus c, where a is not equal to 0. A positive a will give a minimum value, while a negative a gives a maximum value. The vertex tells you where to find the absolute maximum or minimum of the graph. The roots, or the x-intercept, is a point where the graph cuts the x-axis. There can be one root, two roots, or no roots.